Hey guys, welcome back to my CNC mill project. This is just a quickie update. Actually an admission that I make mistakes. This will cost me a little bit of money though. You recall that I have two VFDs in here. One of them is obviously for the spindle. My spindle's 3 horsepower, so I got a 3 horsepower single phase VFD, and this other VFD is for my knee, and I'm actually going to use it for the coolant pump as well. The coolant pump is 3-phase in this machine. I was going back and forth on whether or not to change out the coolant pump to a single-phase coolant pump and just run it directly through the all-in-one DC's flood coolant pump circuit, which has got a relay, it's fused, and that would be one less thing I had to deal with. But the cost of a flood coolant pump is a couple $100. So I decided I'll go with the all-in-one DC schematic and install a CNT2 contactor 2, which controls a 3-phase coolant pump. So anyway, I powered up the machine. I wanted to test the spindle, make sure the VFD's working. I wanted to test the knee, and I was testing the knee and it stopped. So I came back and looked at the VFD and it tripped. So I reset the VFD. It went into an overload. They have automatic protections in them, so it went into an overload condition, and I tested again. It tripped. So what the heck? So, you know, one thing I didn't do that I should have done was take the cover off the knee motor and check the motor nameplate, and I didn't do that. I assumed, I'm like, surely that knee motor can't be more than a horse. So I ordered a horse VFD. Bad mistake. The motor's a horse and a half. And the size of the knee, and having a 10x54 table on it, it was definitely a little bit too much for this little VFD, so now I have to change it out. So I bought a new VFD. I bought a 2 horsepower VFD from Dealers Electric, and unfortunately it is not the same physical size as this 1 horse. It's the same physical size as the 3 horse. Now I've measured, and it's going to be tight, but it'll fit in here. You know, so VFDs need to stay cool. They have their own fans in them, and then the way I did my cabinet, I did cross ventilation. So what ends up happening here is air comes in through this paper air filter here on the side of the cabinet, and the airflow is this way, and it's going up, and then it's going out the louvers on the side of the cabinet. So hopefully, you know, just the air is going to be moving across this stuff, and hopefully, you know, pressurize the cabinet, keep dust out. But it's moving across the cabinet, so hopefully it'll keep the VFDs cool. And this VFD is only going to be used a couple of times when I move the knee, very briefly, so there's not a constant load on it, is what I'm saying, like the spindle VFD. And then the flood coolant when it's running, which is negligible. The flood coolant pump at 220 volts 3-phase, it draws like 0.3 of an amp, so it's nothing. The other thing I wanted to show you guys is the cabinet go boom when I power it up. I have a start contactor in here, so from the operator console, when I press start, this contactor closes and energizes everything. Now in hindsight, I really didn't need it because my switch on the side of the cabinet is very accessible. I could have, you know, I have things moved out of the way. Right now there's usually a drill press right here in this section of on this side of the mill. But anyway, I went ahead because I already mounted it, wired it. It's a little bit more convenient to turn everything on and off from the front. So let me start it, and then we'll go over what's happening. Here we go. So you'll notice the VFD started to come up. You might see them blinking, and then they shut off. So what it did is it tripped my circuit breaker, and I have a 20 amp dedicated circuit breaker for the control. And I started doing a little bit of research, and what's happening is the initial inrush, the charge to the inrush to charge up this big DC capacitor is what's causing the problem. It's just all of a sudden it's a huge surge, and it's a little bit too much, and it trips my circuit. So I've got to fix that, and it's a little device. Here's what it is right here. It's an Inrush current limiter. As I understand it, there's a resistor in there, and what it does is it actually slows the flow of current into this thing, so it's not a huge inrush of current, so it doesn't trip my breaker. Now, you know, I never realized that this was probably on the old control that this thing came out of, my Mitutoyo Millstar 3 control box. And you know, I probably didn't notice it was there. It had to have been, because it never gave me trouble before. And then I looked at Centroid's website, and they have a capacitor with their bridge on a board right on top, bolts right to the top of this capacitor. And guess what? It has one of these on it. So if you find yourselves in the same predicament, when you start your control, it's tripping your circuit breaker and you're scratching your head, because I took my meter to it looking for a dead short initially. It didn't take me very long to figure out this was an inrush problem. But if you run into a similar problem, you need one of these. This is an AS32 2R025. AS32 2R025. It happens to be what Centroid uses on their capacitors, so I got one for mine. If you don't have this, I mean, it's not difficult to build. It's a big capacitor and a bridge rectifier, but you're going to need one of these, especially if you've got a large capacity capacitor, as I do. The other thing too, I want to talk about this a little bit, is this has a bleed resistor across the capacitor. Now when this thing fires up, you apply voltage to it, it charges that capacitor to over 160 volts, whatever rectifying 110 volts AC is. It charges that capacitor up to about 160 volts. So that's dangerous, so you need to be very well aware of it. Now this bleed resistor, its job is to slowly bleed off that voltage to make the capacitor safe to be around, so you definitely need to put one of these on there. Let's see if I can figure out what it's a wire wound resistor. Make sure you have that and be aware of those terminals right there. That's some high voltage that'll get you. You know, and it goes without saying when you're working on this stuff, you know what you're doing. If you don't, get a friend or somebody that can help you out. You know, you need to be safe around it, and you need to build it and be safe. The other thing I mentioned in a previous video is these Quinch-Arc suppressors that go on the coils of the relays, whether it be AC or DC. They're on. I've got three relays here, and they all have the Quinch-Arcs on them. So make sure you put those on there. It helps with noise that can cause some havoc with the electronics on the control. So the other thing is, you'll see that most of this is wired. I'm super close. I'll probably have this thing up and running here soon. I tried different ways to try and be able to get in here and videotape, you know, wiring it. It was very difficult. You get to concentrating on what you're doing so you don't miss things or miswire or land wires on the wrong terminals and so forth. So what I'm going to do, I have a very large dry erase board. I'm going to put I'm going to continue the back panel segments with wiring the back panel on the dry erase board, so it'll be clear for you. I think Centroid's installation instructions are really good about key components, and their print, while it's pretty busy, there's a lot on it. It's fairly clear, but if we take it one step at a time, maybe it'll make it a little bit clearer for you and a little bit easier for you to understand. So I'm going to take the time to go back and do that, and I'll post a series of videos on wiring the all-in-one DC on the dry erase board, where we can discuss it and we can just go point to point with wiring. Alright, so that's where I'm at. And I just wanted to update you guys and let you know what's going on, talk about the mistake I made with the VFD and this Inrush current limiter device that needs to be put on. This goes on one of the AC legs going into the bridge rectifier down there. So it's, I think Centroid's capacitor bridge is much more elegant because everything's mounted on the top. This is all on there, and you just got terminals for AC and you got terminals for DC out. So I'll have to figure out how to get this on there, and I don't think it'll be too difficult, but I have my bridge mounted down below. So anyway, that's where we're at. Yeah, I thought this was important. I'm fixing my mistake, my laziness to take the cover off the knee motor and ordering the wrong VFD. So I have to re-drill the back panel. Well, what I wanted to show you guys is now that where I have to drill is right over components. It's over the all-in-one DC, it's over a power supply, gonna make chips. So if you've got to do something like that, then you need to do something like this. You know, make a, I took some plastic and I taped it to the back panel here, taped it very well. I got my marks, you know, I'll get my drill in there, I'll drill my holes, and then I'll use my small shop vac to vacuum up the chips. What you don't want is chips falling into the all-in-one DC, into its circuit board. You don't want to be drilling on your back panel over your all-in-one DC or other electronic components. That's just asking for trouble. You know, you get those little fine chips in there and you end up shorting something out and you've ruined your board, and that's not something that Centroid's likely to warranty. So take the precaution. That's why it's better to lay out your components, put them on the bench, and drill everything out and mount it. But, you know, things happen and I've got to fix it. It's not practical to take this all apart now, so I have to drill that back panel. It's a steel back panel. I think it's about 1/8 inch steel plate. So it is what it is, but I wanted to show you guys, make sure you do something like this. Masking tape, plastic, garbage bag, whatever, shield it, drill it, suck up all those chips, and then you have to, precaution, take some air and canned air or whatever, lightly blow the all-in-one DC circuit board to make sure you didn't get anything on it. So that's it.